Hello viewers. Now we are going to see about the principal mechanical properties of the solids. So if you are taking the subject mechanics of solids, first you have to understand what are the different properties of the material. So then only we can understand that how it will behave under different conditions of loading. So if you are taking the mechanical properties are strength, hardness, and malleability, elasticity, fatigue, creep, impact, strength, etc. So these are all the different properties of the solids. So now we will see the things one by one. If you are taking that, why we have to understand about the mechanical property. So here, if you are taking any material, if you are taking the mild steel, aluminium and glass, it will behave differently under the loadings. If I am applying the load on mild steel, tensile load, it will elongate. So same load if I am applying to the glass, it will break. So since it's the property of the material is different. So therefore, before using the material in construction or anywhere, we have to understand the property. So it is nothing but to know about the material property under different types of forces, loads, and also in different environmental conditions. And if you are taking that the selection of material, it is very important. So it will be varied according to the applications. And also we have to ensure the structural integrity. So since all the components what we are designing, it should withstand the expected loads and also the stresses. And we have to get the performance optimization. So it should balance the weight, strength, cost, durability, etc. while we are designing. So if I am talking about the strength, it is nothing but ability of the material to withstand the applied forces without making any permanent deformations. So here this is a graph which is showing the load deflection curve, that is a stress and strain when any mild steel which is subjected to the tensile load. So for this we are using the universal testing machine, and we are plotting the graph from the results of tensile strength of the mild steel. So here if I am taking that this is a graph, stress strain graph. Here you can see this different points: proportional limit, yield limit, ultimate limit, fatigue limit. So here if I am taking the tensile strength, it is nothing but the maximum stress before the failure. So yield point means it is the where the material starts to yielding. So if I am taking the proportion limit, if I am unloading the loading of the material, it will regains its original shape and size. So this is the proportion limit. And next we will see about the elasticity. So it is the ability of the material to retain its original shape even after removing the load. So after that there will be the permanent deformations will be there. So if I am taking the ductility, it is a very interesting property. So here whenever the materials is undergo sustainable plastic deformation before the rupture, that is provide a very warning signs to the failure. So and if I am talking about the brittleness, so it is the if I am taking the class, if I am taking that if I am applying the small load also, it will break. So it is nothing but the brittleness. And the toughness. So what is the toughness? So whenever we are applying the load, and if you are whenever we are applying load, that material will start absorb some energy without any fracturing. So this is the how we can measure when we are drawing a graph, stress strain graph. The area under that stress strain graph will give the toughness of the material. So the next one is a hardness. So it is nothing but the material resists localized plastic deformation caused by the mechanical indentation or the observation. So for this we are using the Wickett, Rockwell and this material for finding the hardness of the material. And next one is the stiffness. So it is a measure how the material will resist deform when an external or elastic force is applied. So it is directly proportional to the Young's modulus. Okay. So when the Young's modulus changes, the stiffness will also change. And the next one is the fatigue. So whenever we are applying the cyclic loading, so there will be the progressive structural damage will occur. So failure can occur due to that cyclic loading. So studying about that is nothing but the fatigue deformation. And the next one is the impact load. So it is nothing but sudden applied load. If I am taking the tensile load, so it may be the gradually applied load. The impact load is nothing but the sudden applied load. The material should withstand that sudden applied load without any fracturing. It is nothing but the impact resistance. And next one is the fracture toughness. So here whenever if you are applying the load and if you are finding the propagation of cracks, okay, so the material having that ability to withstand the fracture in the presence of crack also. So it is nothing but the fracture toughness.